Hopefully we can hear myself because I unplugged everything from my computer today. So here I've got this lovely problem, and we're reviewing piecewise functions for my lovely audience at home. And so what is the first step I'm going to do? Raise your hand and tell me the very first step. Jake. Good. Good. So Jake wasn't sure right away, and I know the people at home can't see that. So Jake did something very good. He turned over his notes and looked at that. Okay, that's why I waited. I like that, Jake. All right, so we're going to plug in 2 to both of the functions, right? So I plug in 2 to the top function. What number do I get? Somebody other than Jake this time. -2. So I'm going to write that as an ordered pair. 2, comma, -2. That makes sense? Now, I'm pretty sure Mackenzie could easily do that one in her head. If it had been a fraction, do you think I want to see some work? Yes. In that case, I assume you can do negative and then plug in a 2 in your head. I'm okay with that. Do that to the second one. They are? Good. So 2, comma, -2. You guys see where I'm getting the 2 from? Okay. So this is one of the weird ones that if you did last night's essential work, you may have been saying, I don't quite get it. Because on yesterday, I gave you 2 separate points, right? One was closed, one was open, right? Well, now I have a closed point and I have an open point. What do you see? Yeah, you only see the closed point, right? Because the closed point covers up the open point. So, at 2, comma, -2, I'm going to put a nice big closed dot. Not just a regular little dot, just to make sure I can easily tell that's your solid dot right there. All right. Let's pick graded. Graded. Can you read me this? Good, pick a friend. And what's the, which way is greater? Wait, oh, by the way, I'm bad with left and right. Is it on this side or is it on this side? You can, okay, thanks. Said positive, I know where that's at, okay. I have trouble with left and right, I'm not going to lie to you. If ever you end up riding in a car with me for some reason, if you're giving me directions, you point. Don't tell me to turn left because I'm going to turn the opposite way somehow. I don't know why. Okay. Pick a friend. What's the slope of that line? And what does that mean to do? Good. Down and to the right one. Down to the right one. Notice that the dots I'm putting on are not near as big as the original dot, right? They're just regular dots to help me draw my line. So now I'm going to connect those and make a ray. For those of you that have geometry, you learn a ray has a starting point and goes on forever in one direction. So far, okay? Sabrina, pick a friend. Can you read me this inequality? Perfect. Is that on this side or this side? Perfect. So she's saying it's on this side over here. Have to put a little star for our audience at home. Pick a friend. Angela, what's the slope of my line? And what does that tell me to do? So if I go up one into the right one, am I on the side that Sammy told me to be on? So what do I do instead? Very good. So I'm going to go down one to the left one. Now, notice how Angela's first thought was to go up one and to the right one. Angela, that should be everybody's first thought, every single time. But then she just has to think back, okay, that's not the side I want to go on, I'll go the other way. And I'll connect those, making a ray. What letter does this make that's upside down still? I know. It is a V. You guys see that? Okay, so I know I'm not teaching Friday's lesson today, but this actually will lead us into Friday's lesson. On Friday, I'm going to teach you how to graph absolute value equations. Sounds hard, right? It's actually very simple. A lot easier than this. If you thought this was hard, absolute value equations are pretty easy. But they'll look like this. Y equals, this is a negative slope. X minus 2 minus 2. Now you don't need to write that part down. But this equation that's up here in blue is the exact same as this purple equation. Which one looks easier? The top or the bottom? Bottom. And on Friday I'll show you how to graph those. But are all piecewise functions these? No. So that's why we need piecewise functions, because they're not all pretty in these. So what's the other type of piecewise function that we gave a name to yesterday? That's perfect. Let's do a step function. I need to add in my little thing there. I'm going to hit pause. So yesterday we actually graphed piecewise functions, right? But we didn't graph something that looks entirely like this. In fact, the top and the bottom equation are a little different than we've ever seen. But these middle three equations, this one, and this one, looks like what you did yesterday, right? The only difference is 9.1. So I wanted to throw in a decimal number so you weren't thinking it's always like a perfect number. If I was graphing 9.1, should I put it on the line of 9? Sammy's saying no. Why? Sammy, you're right. It's not 9. So where should I put it? Should I put it at 10? So where should I put it? In between someone. Okay? My guess is that if I look at Angela's and she does 9.2 instead, would I really know? No, I wouldn't. Okay, so somewhere between 9 and 10, probably closer to 9. What I want you to do right now in your group is to graph just those three starred equations at this time. So I want to go back over this one more time. And you actually wrote a note to your future self. And some of you are learning that the notes you write to your future self are actually very important in here. I don't do it very often. I don't make you write notes to your future self a whole lot. But when you do, and it's a brand new topic, usually future self doesn't remember what's going on, right? Usually. So let's take a look. These over here are my x values, where this is my y value. So I'm going to go to negative 8 on my x, and up to 6. And what kind of a dot will I put right there? Good, open. Then I'm going to go to negative 6, and up to 6. And what kind of a dot will I put there? Yell it out, guys. Closed is right. That makes sense so far how I got that first line. Okay, I'm going to do it again. I'm going to go to negative 6 and up to 8 and put an open dot. How about negative 4, 8? Good. Now, negative 4, 9.1. Notice I'm slightly above that line, right? Just slightly. If it's not perfect, that's fine. Just try not to make it exactly on the 9 line. And then here, I'm going to put a closed dot and connect those. That makes sense so far? So now what I want to do is I want to graph that top equation. And notice it's telling me to graph y equals 4 if x is less than or equal to negative 8. So I'm going to find negative 8 on the x-axis and go up to 4. What kind of a dot will I put right there? Uh-oh, what kind of a dot? Good. Does that make sense to everybody how I got a closed dot? Because that has equal sign, right? Okay. And this is one you didn't see yesterday. That's why we're purposely waiting and going over it now. And notice it's telling me x is less than or equal to negative 8. Does it give me an ending point? Like is negative 10 less than or equal to negative 8? Negative 100? Negative 500? All of those are less than, right? So my arrow that's going this way is actually going to go on forever that way. So I extended it just so you could see, like look, it's going on forever. You don't have to make it go off your graph. It should go to the end of your graph, though. And now what I want you to do is to graph this one using what you just learned by yourself. There we go. So I'm going to go to negative 2 on my x, up to 10, and put what kind of a dot? Everybody yell it out. Open. Good. And it's going on forever this way. There we go. That make sense? So if there's no ending, it's going on forever. And I actually think these look more like real stairs than just having steps. Because look, down here's your gymnasium, right? It's all flat until you get to the senior high steps. You walk up the senior high steps, now I'm in the senior high, it's all flat. That's more real life, right? Yeah. Okay. So, in just a second, we're going to give you some time to do this lovely essential work. But before we do that, we have a few tasks that we want to do. So for those at home, this is the essential work. And for the rest of you that are sitting here currently in my audience, we'll do this in a second.